Setting up my Chem 106 Lab 1. First lab in Chem 106, the hot packs, cold packs lab, okay? So this is the setup here. Stir plate. We have two nested coffee cup calorimeter here, two styrofoam cups. We have a thermistor monitoring the temperature. Inside I have a stir bar, right? We start off with no water in there. All right. We also want to make sure that before we start, there's no residual salts in your cup. We also want to make sure that there's no residual water, right? So I'll be drawing it out.
Yes, and it's at 150.
He has lab today, his meeting is 150. Nice. Yeah. Okay, so I'm going to just dry this out and make sure that I don't have any residual water in there. All right. There we go. I got this Microlab from the drawers over there, right, by the backpacks and stuff. I have to make sure the Microlab is plugged into the computer through this USB cable and also plugged into the wall. Correct? All right. I have to make sure that I have the thermistor here, and the thermistor is going to plug into one of these three options there. Whoops, this is not right. That'll do. Okay. All right. I can make sure that my power is on. There's the power button there. You can tell that the power is on by that light there. All right. And then, oh, looky there. It's an old, what's it called? Or was that yours? Is this yours?
No.
Was this
Oh, I
yours?
think so.
It was? And the safety was too?
Oh, no, maybe not. Maybe not.
All right. Then I can go into the, I'll just close this just so we can show people from the beginning. Right? Right here, Microlab is where we're starting. Double clicking there. And I have to make sure I see that thing. If I don't see that thing, then it'll make me think I've opened the software and I'll work on something that's not actually there. All right. So, Microlab, double click there. And then I'm going to add a sensor. I want to sense the temperature. And it's going to be thermistor, the first one. And I'm going to click on this one here because that's where I plugged in down here. All right. So I'm going to click there and then say use factory calibration, and then this should give me a temperature which is, close to room temperature. It's the change in temperature that we're after, so the absolute temperature isn't terribly important. All right. I can drag this up to here. I could also drag this over to here, right? And now I also want to plot the temperature versus something, and I'll be using time. So I'm going to add another sensor. This time I'm going to add just a timer. I can have 3 timers going at the same time. So I'll use seconds. Finish. All right. And that should be good. Now I can put the time up to here by dragging this up to there like that. And I can also drag it over to here. Now I'm ready to start. And I'll just do a quick practice here by pushing start. And you can see that it starts monitoring the temperature every half a second. All right? It looks like it's working okay. And then I can push stop here just as just a practice to show how it works. And then I could say repeat experiment, and it'll give me an option to save. I'm not going to repeat experiment without saving that last data. Then it says, are you sure? I don't want to see that again. So, okay. So now it's ready to start the next one. So the procedure says to get 100 milliliters of water, 100 grams of water is what it says. So I can use this volume here, 100 milliliters. Okay, make sure it's right on. All right. 100 milliliters of water. Okay, I want to make sure that this is stirring relatively, whoops, you didn't quite get this plugged in. Wonderful. Okay, and then following along the experimental procedure here, it says, running the experiment, here we are, right? 100 milliliters of distilled water in a graduated cylinder, pour in the water, right? Take a weigh boat, weigh the nearest 0.01 grams of magnesium sulfate, all right? 5 grams of magnesium sulfate. So, let's see, do I have magnesium sulfate? Push pause. Okay, so I'm going to weigh out our 5 grams of magnesium sulfate. .7, 4.8. All right. We got it. So, we can now, we're ready to add this into there. Where's our lid? Do I have a lid? There's, it's nice to have a lid on when we're done. Not that there's a huge amount of transfer or heat loss through that lid. We're ready now to push start. It's good to push start a little bit early and allow a good baseline to develop, right? So that there's no doubt what the initial temperature is, which is 22.58. Okay? Now, I need to make sure this stuff all drops in here. And in this one, it was the case that these were all powdered. I need to make sure it all goes in there. There we go. This was all very powdered, so it wasn't a big deal. But you have to make sure that the salt that you're adding is nice and fine. If it's clumpy, then they'll just get down to the bottom and you'll have a lot that doesn't dissolve. So that's a problem. All right, so we see our change in temperature already occurring there. And we want to allow the measurements to continue, it says, for a couple minutes. So after a couple minutes, we'll be able to stop and identify our change in temperature. Okay? Right, that's probably, well, actually, it's still going up a little bit. We should let it go a little more. You can push pause. All right, so with our data here, now we want to identify the temperature final and temperature initial. The temperature initial, we can just go ahead and rest the mouse over on the bottom left there.
Here?
Yeah, just move it just up until it gets to the red line. hold it right there and just wait. Now it'll, there, so it's 22.5, all right? And then go up to the highest point, which is right about there, yeah. $29.65. So, and the temperature initial, what was the temperature initial? 22.5? So now we have our temperature initial and temperature final, and that's going to give us our change in temperature, which is temperature final minus temperature initial. All right. And that change in temperature, right, this one here, we're going to multiply by our heat capacity to find out how much heat was released in this process. Okay? And the lab here on the second page, the heat capacity for this calorimeter has a value of 463 joules per degree Celsius. So that's what we'll have here is 463 joules for every degree Celsius that's being shifted. So our change in temperature here, right? 29.65 minus the 22.50, what is that? 7.15, is that right? Okay, so 7.15 times 463. Well,
It's 3,310.45.
3,310.45 joules. This is in units of degrees Celsius, so just cancel it out, right? Okay, so that's how much energy was released by 5 grams of magnesium sulfate. Does that make sense? So we see that the delta H of solution of the magnesium sulfate, right? We'll want to answer, we'll want to have in terms of joules per mole, something along those lines, right? So this is right here is, that's how many joules you get for 5 grams, right? And we would like to know, for example, how many joules per mole of the material. You know that 3310.45 joules is released for 5 grams of magnesium sulfate. And we can convert grams to moles of magnesium sulfate. And then we'll have our answer in joules per mole of magnesium sulfate. All right? So that will give us the delta H of solution of magnesium sulfate. Does that make sense?
Yeah.
All right. So that is how our first round of calculations are going to go. Another thing that you want to do for your lab report is you want to be able to successfully export this lab or this data right here. To do that, we can say save, and we can say export data to an Excel file. Click that there, and we can. I'm going to save it on the desktop. I'm going to call it something like, that I can find quickly. And it's going to open it for me, and I can highlight it like that. and then make a scatter plot, just like it was a second ago. There now, I have a table that I can put into the lab report. I can also right-click here and format that axis so that instead of having to have so much of a figure for just a small amount, a small portion of the data, I can adjust the axis so that the low range is maybe a 20 to start off with. That make sense? And I really don't need past 125, so I could even adjust this axis to go just as high as 140, like that. Okay? So that's another thing you're going to be able to do to export your data. All right? Good. That's a good place to stop. We'll stop.